Today we are going to discuss about knocking. What is knocking? Knocking means, do you think this is knocking? Knocking a door is knocking? No. Knocking occurs even in an engine. It might be petrol engine or it might be diesel engine. How this knocking occurs, let us see. So before understanding what is knocking, we'll discuss the working of IC engine. Might be 2-stroke engine or 4-stroke engine. Later we'll discuss the mechanism of knocking, control the effects of knocking, and how to control knocking. So in this session, so engine works. Now the engine has a piston. So engine works in 4 steps. So before discussing the knocking, let us see the engine functioning. So this is the engine. So engine will have 2 inlets. One is inlet valve, other one is outlet valve. So engine, this is, let us think this is an engine. So engine will have 2 valves. This is inlet valve, this is outlet valve. So it will be having 4 steps. In the first stroke, the fuel air mixture will come through the inlet valve. So as soon as this comes, the outlet valve will be closed. In the first step, the inlet valve will open, the fuel air mixture will come, and when this will close. In the second step, the fuel air mixture will be compressed by the piston. Okay, you can see that the movement of the piston here. The fuel air mixture will be compressed. In third stroke, a spark will be produced to ignite the fuel, and the fuel undergoes combustion, and the products of combustion. What are the products of combustion? Carbon dioxide, carbon monoxide, water, etc. will be liberated, and energy will be liberated. The energy will be used for some other purpose, whereas the exhaust gases will come out through the outlet. So until the fourth stroke, the outlet will be closed. So if this occurs properly, it is called as smooth combustion. So knocking occurs in case of explosive combustion. What is explosive combustion? I'll tell you. So what is first stroke? In the first stroke, the fuel air mixture, this is the inlet valve will open, outlet valve is closed. The fuel air mixture will come inside. Next, in second stroke, the fuel air mixture will be compressed using the piston. So when it is compressed, what's happening? The pressure is increasing. As pressure exerted is increased, temperature also will increase. As temperature increases, part of the fuel will undergo combustion. In the second stroke itself, before come to third stroke. When the fuel undergoes combustion, some products will be produced. These products want to escape and go outside the engine, but the outlet valve is closed. This will hit the inner walls of engine and piston, okay, making a rattling noise which is known as knocking. So there is a small, before the third stroke, spark should be produced, right? But in second stroke only combustion occurs, and the intermediates will be produced, hit the inner walls of engine and piston. So it cannot go outside, it will be moving inside the engine. After, in the fourth stroke itself, it will open, in the fourth stroke it will go out. Until then, it will be roaming, wandering around in the engine and piston, making some type of noise that is called as knocking. Okay, so this occurs in a 2-wheeler, 4-wheeler, 6-wheeler, anything. So how to prevent, what are the ill effects, we'll see. So before that, there is a small video, we'll see how this knocking occurs and how to minimize this knocking. Okay. So like regular combustion. There is smooth combustion occurs here. This is smooth combustion. You can see right side, fuel air mixture has come. The piston has fuel air mixture is compressed. Fuel undergoes combustion. The outlet valve is open and going out. This is regular combustion. In case of knocking, here. When the fuel air mixture is compressed itself, will undergoes combustion. When it compresses itself, fuel undergoes combustion. It's very well animated. This is for pre-ignition. That is why knocking occurs, because of compression ratio. What is compression ratio? I will tell you. Before the third stroke itself, ignition occurs in the second stroke only. But when fuel air mixture is undergoing compression, that time itself ignition occurs. It is called as pre-ignition. Of course, you can minimize that by various methods. See, now pre-ignition does not occur. So tightening the torque, to some extent it reduces the pre-ignition. This is regarding your ignition. Okay. So let us see why knocking occurs and what are the products produced during knocking. So why knocking occurs? Compression ratio, because of increase in compression ratio. What is compression ratio? So compression ratio, so the ratio of fuel air mixture, ratio of engine before and after compression is called as compression ratio. As compression ratio increases, what will happen? Efficiency of the engine also will increase to a certain extent. Once a threshold is reached, or explosive combustion occurs, producing a rattling noise which hits the this explosive combustion occurs producing various gases, intermediate gases, which hits the inner walls of engine and piston, producing a rattling noise which is called as knocking. It's called as knocking. Let us see what are those gases. So if engine occurs, in engine, if normal combustion occurs, so fuel. So we are going to consider ethane as a fuel. Fuel undergoes combustion, and if all the four steps occurs properly, then we get carbon dioxide, water. Then there is no knocking. But that is not the case in any type of vehicle. There is an ideal vehicle, ideal engine. So what will happen? Fuel, as soon as it undergoes combustion, so an intermediate will be formed. So in the second stroke itself, what will happen? Fuel undergoes combustion, okay, and it will give some intermediates. So methane, ethane undergoes combustion to produce dimethyl peroxide. So this dimethyl peroxide again oxidizes to give acetaldehyde. Acetaldehyde undergoes further oxidation to give formaldehyde, and formaldehyde further undergoes oxidation to give carbon dioxide, water. So these intermediates will be in the form of gases and under high pressure. These will hit the inner walls of engine and piston with high pressure, thereby giving a rattling noise called as knocking. So this is why our knocking will occur, because of these gases. These gases hit. I'm just knocking the table. You can see how much noise is produced. So just imagine this engine hitting, gas hitting the inner walls of engine and piston. So how much noise will be produced? Right. So if knocking occurs, what are the effects? So what will happen? Because of this knocking, driving becomes unpleasant. It will give an irritating noise, isn't it? So it will cause the damage to inner parts of engine. So these aldehydes will get converted to acids. So these acids will corrode the inner parts of engine. Thereby the life of engine reduces. The output of engine will be less, efficiency also will be less, fuel consumption also will increase. So these are the effects of knocking. So now how to control knocking? The only thing is to control knocking is to maintain critical compression ratio. So if you're maintaining critical compression ratio, then knocking can be minimized. So once knocking is occurred, so to the fuel you can add, as you're adding lubricants, you can add anti-knocking agents. So when you use anti-knocking agents, we can minimize knocking. So what are those anti-knocking agents? We're going to discuss in our next discussion. And maintaining moderate temperature and pressure also we can minimize knocking. Okay. So the next discussion will discuss about anti-knocking agents. Thank you.